Jai Hind. I am Professor Devendra Singh, HOD Mechanical Engineering Department at Ajakmar Garg Engineering College. I am taking the course on machine design here, and in the last uh, video, we have discussed about the standards, standardization, benefits of the standardization, standard elements if we are using in our design may affect the cost, may give the cost effective design, may be provide the ease for maintenance, running cost and maintenance cost may be reduced. Then we have discussed the selection of preferred sizes to satisfy the needs of our society for a particular problem. If we design something, it should be satisfied, or it should be provided the solution for the problem with the minimum optimal number uh, of designs or product. So that is that thought, that series selection of preferred sizes method was proposed by uh, Charles Renard, a French balloonist and engineer. And there are 5 basic series. He suggested R5, R20, R10, R40, R80, and each and every series is having a fixed series factor. That's why we are having a some logic behind selection of the various sizes of a product to satisfy the need of the society, and thus the designer avoids the arbitrary selection for the sizes. And sizes is a general term. It may be in terms of the capacity, it may be in terms of the load carrying capacity, it may be in terms of the dimensions of the product, etc., etc. Today we are going to discuss about the BIS designations of steel in this lecture. So the contents of this lecture is introduction to steel. That is, steel is an alloy of carbon and iron primarily. Then classification of steel on the basis of the percentage of carbon and other classification we will discuss. BIS designation of plain carbon steel. Then this is BIS stands for Bureau of Indian Standard. Then BIS designation of alloy steel and selection of materials. These are the 5 topics or 5 topics we will discuss in this lecture. So first of all, what is steel? Steel, as I have mentioned, it is an alloy of carbon and iron. So as ISO standard 7598 and 1990, steel shall be classified as unalloyed steel. This alloy carbon and iron, we need some specific characteristics or specific uh, properties of the steel. Sometimes we add some more elements, then it will be called the alloy steel. And unalloyed steel, where some components or some elements which are having certain average percentage content or lower than that, then it is called the unalloyed steel. Definitely steel is a primarily alloy of the carbon and iron, and it will contain even more elements in the steel. Then alloy steel, where we are having some significant average percentage content other than the carbon with iron. So that is alloy steel. Unalloyed steel are those steels in which a specified content of any element is less than that is indicated in this table, like aluminium. If it is 0.10 or less than 0.10%, boron is 0.0008. If percentage is more than 0.0008, then it will not remain the unalloyed steel, then it will come into the category of the steel. And similarly, we can get these percentage in our standard IS 7598 1990 to find whether this is an alloyed steel or alloy steel. If any element is having more percentage than this specified percentage, then it will come into the category of the alloy steels. Then alloy steels are those steels where specified content of any element is equal to or greater than that indicated in the table. Depending on the alloy content, exclusively of sulfur, phosphorus, carbon, and nitrogen, alloy steels shall be subdivided as follows. This is low alloy steel. What is low alloy steel? If the total percentage, average percentage of the all elements, if we sum up, and it is up to 5 or including 5, that is called a low alloy steel. A medium alloy steel, if this sum of the alloying elements, our average percent content, lies between 5 to 10%, then it is called the medium alloy steel. High alloy steel, if this sum is more than 10% in total, then it is called the high alloy steel. The plain carbon steel have varying from 0.06% carbon to 1.5% carbon are divided into the following types depending upon the carbon content. So first is the dead mild steel. If the carbon average percentage content in the steel is up to 0.15% carbon, then this steel is called the dead mild steel. Then low carbon or mild steel, the carbon percentage on an average lies in between 0.15% to 0.45%. Then this is called the low carbon or mild steel. Then this is medium carbon steel. If the average percentage content uh, lies in the steel 0.45 to 0.8%, then this is called the medium carbon steel. And the high carbon steel, if the average percentage content of the carbon in the steel lies in between 0.8 to 1.5% carbon, is called the high carbon steel. And if percentage content is more than 1.5%, we consider it is in the category of the cast iron. Now the BIS designation of plain carbon steel. So there are two ways to designate a plain carbon steel on the basis of the mechanical properties, primarily based on the strength, and on the basis of the chemical properties. So on the basis of mechanical properties, this is an example. Fe is the symbol. This Fe is the symbol of Fe is the symbol of iron. This is symbol of iron. And 350 is the minimum tensile strength in megapascal. This is the plain carbon steel which is having the minimum tensile strength of 350 Newton per mm square or 350 megapascal. Similarly, another way, this FEE here, this capital E we have included in this designation, then this is again signify a plain carbon steel, but now this 350 if I am using, this is the minimum yield strength. This will designate the minimum yield strength of that plain carbon steel. This is the way of the plain carbon steel to designate according to BIS on the basis of mechanical properties. With capital E, then the following digit or following figure will indicate the yield strength, minimum yield strength of that plain carbon steel in megapascal. If it is without E, then this is the minimum tensile strength. This figure indicates the minimum tensile strength of that plain carbon steel in megapascal. Now, on the basis of the chemical properties, we can designate a plain carbon steel as a figure. First, we will write a figure indicating 100 times of the average percentage of carbon, then followed by C, then followed by 10 times of the average percentage of manganese. Mn stands for manganese, and here for illustration we have taken an example. Designate the steel comprised of 0.4% carbon and 0.8% manganese. So plain carbon steel, first digit we have to multiply 0.4% by 100. This is the first step to designate. So it will come out 40. Then following by capital C, we will write, first we calculate the average percentage of manganese multiplied by 10. So 0.8 multiplied by 10, it will come out 8. So according to this, I will write first 40, that is the 100 times of the average percentage content of the carbon, followed by a capital C, that is the chemical symbol of carbon, followed by 10 times of average percentage of manganese. The 40C8 is the BIS designation of the plain carbon steel. Then we have next question is 10C4. What do you mean by 10C4? So this 10C4 indicates, first indication I will get, that is it is a plain carbon steel. It is straightforward. It is a plain carbon steel. Then what is average percentage? Average percentage of carbon in this is 10. This is here, it is 100 times. So divided by 100, it is 0.1%. This may be 0.8 to 0.12%, maybe variation, but this is an average carbon percentage we can get. And the C, capital C, is the carbon. And now this 4, it will indicate the manganese. So average percentage of manganese in plain carbon steel is 4 by 10 is equals to 0.4%. So this is the meaning of 10C4. If BIS designation is available or given, we can find out the average percentage content of the carbon and the manganese. Then we come to the BIS designation of low and medium alloy steel. First, the alloy steel we have discussed earlier. If the elements added in this steel is more than the specified percentage in the table we have discussed in the last slide, is more than or equal to that, then that is alloy steel. Otherwise it is unalloyed steel. Now what is low and medium alloy steel? That we have also discussed in the last slide, that if the total sum of the average percentage content of the alloying elements is up to the 5%, then it is low alloy steel, and if it is 5 to 10%, then it is medium alloy steel. So for the designation of the low and medium alloy steel, the very first step, again, it is having 100 times of the average percentage of carbon, as we have already used in the plain carbon steel. Next step, in place of capital C, that is the element, that is the symbol, a chemical symbol of the carbon. Next, this 100 times of the average percentage of carbon, followed by a chemical symbol of the major alloying element. Major alloying element is that element which is having the maximum average percentage content in the steel. Then this the symbol of the major alloying element will be followed by a figure which is multiplied by a factor, and this after multiplication must be rounded off to the nearest integer, followed by next major alloying element with its average percentage of element multiplied by a factor, and all these average percentage figure after multiplying shall be round off to the nearest integer I have already mentioned, and symbol of manganese shall be included in the case of its content is equal to or greater than 1%. Otherwise, we need not to include the symbol of manganese in the designation of the low and medium alloy steel or any steel. These are the multiplying factors recommended for chromium. For this chromium, cobalt, nickel, manganese, silicon, and tungsten, the multiplying factor is 4. And for here, aluminium, beryllium, vanadium, lead, copper, niobium, titanium, zirconium, molybdenum, this is 10. Similarly, phosphorus, sulfur, and nitrogen, it is 100. These are the multiplying factors. And the use of this table or the multiplying factor will be illustrated with this example. Alloy steel having carbon 0.35 to 0.45% chromium, 0.9% to 1.20. So carbon percentage is here given is 0.35% to 0.45%. So average, if you want to calculate, it will come out to 0.40%. It should be multiplied by 100. Then next is the chromium. It is 0.9. Chromium is 0.9 plus 1.20 divided by 2. This is 2.10. It will be 1.05. And this 1.05 average percentage content must be multiplied by a multiplying factor from this table. So here we find this is chromium here, and multiplying factor is 4. So we will multiply it by 4, it will be 4.20. Then if this, after multiplication, this must be rounded off to the nearest integer, it should be 4. Thus the designation of alloy steel is 40. This is 100%, 100 times of the average percentage content of the carbon, followed by the major alloying element is the chromium Cr. Then it is followed by this 4. So 40C4 is the low, or this is alloy steel, or low alloy steel, because as per the data given in the problem, the alloying element percentage is less than 5% here. This is then another example is, what do you understand by this 25 Cr MO2? This. So if I take, there is no capital C, there is no symbol for the carbon. So it is both, in fact A and B both are alloy steels. These are alloy steels. These are alloy steels. I am not predicting here what percentage is there. First we consider this is low end alloy steel. So here 25 Cr MO2. So it will contain this 25, means average percentage of carbon is equals to 25 divided by 100, that is 0.25. 0.25% carbon is there. Then Cr is 4. Here Cr is 4. So for chromium, the average percentage of chromium this is 4 divided by 4. It is 1%. It is 1%. This is rounded off value 4. It may be 0.8 0.9 multiplied by 4, maybe during the actual situation it may be 3.6. Then it will be around. It might be rounded off to 4. Then average percentage of molybdenum, this is 2. And if you refer this table for molybdenum, this is molybdenum here, the multiplying factor is 10, so it will be 2 by 10 is 0.2. So here actual total alloying element, if I calculate, it comes out to be, 1 plus 0.2 is 1.2. So it is low alloy steel. You can write now here, this is low alloy steel having the average percentage content of the carbon, chromium and molybdenum is this. If I take the B part, that is designation is 40, Ni 8, chromium is 8, and V2. For this carbon, average percentage I am writing here. This is again this alloy steel. So average percentage of carbon is 40 divided by 100. This is 0.4%. Then nickel, percentage of nickel, average percentage of nickel. Average percentage of nickel. Multiplying factor I have to refer. Here for the nickel it is 4. So it is 8 by 4. This is 2%. Similarly, average percentage of vanadium, it is 10. If you refer the table, then it will be 0.2. Again, if I am using this nickel is 8%, nickel is 8%. Yes, nickel is 2%, chromium is 8%. Chromium remains, multiplying factor is 4 for chromium is equals to 8 by 4 is 2. The sum will come out to be 4.2. This remains low alloy steel. So this you can understand the chemical composition of the alloy steels from the BIS designation. Now BIS designation of high alloy steel. High alloy steels are the steels which are having the total sum of the alloying elements more than 10%. So it is designated as we write a letter X as a prefix, then followed by a figure indicating 100 times of the average percentage of carbon content. In alloy steel, we do not write the chemical symbol of carbon. We write 100 times of the average percentage content of the carbon and plain carbon steel as well as the alloy steels. Then followed by chemical symbol of major alloying element as we have done in low alloy steel. Then followed by average percentage of major alloying element rounded off the nearest integer. There is no multiplying factor we are using in case of the high alloy steel. Then followed by next major alloying element with its average percentage of element rounded off the next integer. And example we can take, this is the BIS designation X10, CR18, Ni9. This indicates this X gives that this is high alloy steel. This is high alloy steel. And now what is carbon percentage? Average percentages of carbon is 10 by 100 is 0.1%, 0.1. .1%. Then next is the chromium. Chromium is 18%. We will write as it is, and nickel is 9%. Total is 27%. If we add, this is 27%. So the total sum of the alloying element, average percentage of alloying element is 27% more than 10. So it is high alloy steel. And second example, second designation is X15, CR25, Ni12. So here again, this is high alloy steel. This designation signifies high alloy steel. Then carbon percentage, average, definitely average. Percentage is 0.15%. Chromium is 25%. And nickel is 12%. This is the designation. Now the BIS designation of alloy tool steel. So the designation system is as we have discussed for the low and medium and high alloy steel. Only the difference the prefix we have to use capital T. In case of the low alloy steel, we use capital T only in the prefix of the Bis designation. If it is high alloy steel, we will use the XT in case of the high alloy steel in its designation, proper designation. So here these are the example. This capital T we have added, and there is no symbol of C. So this is alloy tool steel, and percentage content if you want to get. Then carbon, I am writing here the average percentage content. So carbon is 25 by 100, that is 0.25%. Then this is low, so we have to divide it by the multiplying factors. So chromium is 4 by 4. 4 was the multiplying factor, it is 1%. Similarly, molybdenum, for molybdenum we use 2 divided by, I have to refer this molybdenum is 10. So this is 2 by 10 is 0.2%. This is low alloy tool steel. Similar example you will get. This is the low alloy tool steel where carbon, in this case, carbon average percentage is 0.4%. Nickel is 8 by, this is 8 by, and chromium is, this is 8 by 4 is equals to 2%, and chromium is 8 by 4 is equals to 2%, and vanadium is 10, multiplying factor 2 by 10 is equals to 0.2%. Now these two, if we refer these two, this XT gives the indication that it is high alloy steel. These are high alloy tool steel. If this is high alloy tool steel, then the percentage content you can give for XT, I am writing here XT10 Cr18 Ni9. It is having the average percentage of carbon is 0.1%, 0.1%, 0.1%. Then chromium is 18%, nickel is 9%. In the second example, XT15 Cr25 Ni12, it is again high alloy steel, and carbon percentage here is 0.15%. Chromium is 25%. The nickel is 12%. So this is the way we can get the information about the chemical composition about the alloy tool steel. And the last topic for today is the selection of materials. In fact, selection of materials is the most complex and tough task, because a wrong selection of material may affect our design adversely. So the basic 4 factors always we should consider when we select the material, and the basic criteria are the availability of raw material. We should try to use those material which are readily available in nearby zone, so that transportation cost can be minimized and the raw material will be available as soon as possible when we require. So time cost can be controlled in that way. And then the cost, the raw material cost will include the transportation cost and the raw material cost include raw material cost and the transportation cost. If material is not readily available, then we have to get it from other places, and transportation cost will be included, and it will finally affect the cost of the product design product, and it may affect the market of that product. Next is the manufacturing consideration. We should consider what type of the manufacturing processes we need to apply on our design to convert the raw material into the final shape. So for that, for example, some welding is required to make the final product. Then proper weldability must be there. So if machining is required, then it should be properly machinable. Then material properties are required. Light material or homogeneous in construction, chemical and physical properties we need to refer before for selection of material, and these properties must fulfill the requirement of our design. Mechanical properties like elasticity, hardness. If we are designing some tool, then the tool must be harder than the job, then only it can cut, or it can process, it can machine. Resilience, for example, we need to select a material for spring, so it must have the high resilience properties. Ductility, if you want to convert some material into the length, if you want to stretch, you want to apply some convert some plastic deformation is required in the under tensile load, then ductility, proper ductility is required, etc., etc. So various mechanical properties and tribological properties we need to consider for selection of materials for the mechanical design. Then technological properties like forgeability, that we have forgeability, castability, malleability, machinability, weldability, that I have mentioned in the manufacturing consideration. So these are the basic selection criteria a designer should consider for proper selection of material. A wrong selection of material will adversely affect the design. Sometimes, if I say, sometimes it is better to select the material which is having higher material cost, but its transportation is not there, it is readily available, it is processing, it is having the processing cost low. So ultimately the final cost, if it affects or it comes out to be lower than the material which is having the raw material cost is lower, but the high material cost, high cost, or the costlier raw material may result in the cheaper product. So the designer has to select whether this raw material with lower cost but manufacturing cost as processing cost and transportation cost is high, then we need to think about it, what material we should select. But preferably, generally we discuss the raw material cost should be low and transportation cost should be as low as possible. Then ultimately, if we consider both the cost, it will result in the lower least cost. But designer has to select wisely. Sometimes this costlier, costlier and lower processing cost may result in may result in the cost effective product. So the selection of material is a typical step in the design. So for today, this is all about today's lecture. If you have any query, if you have any question, you may ask as per on my details given in the video. So thank you very much. Thank you.